Welcome to Nabeel Math Academy. In this video, we are going to study about the infinite limit. So before going to start the problem, so we have to know the properties of the infinite limit. Limit x approaches to infinity, x power n equal plus infinity, where n is any natural number. And by the way, this limit infinity, we are studying to know the behavior of the graph at the endpoints. What happened in the x approaches to infinity, what is the value? As x approaches to minus infinity, what should be the behavior of the function? Now, if limit x approaches to minus infinity, x power n equal plus infinity if n is even. And here, if it is minus infinity, x approaches to minus infinity, x to the power n equal minus infinity if it is odd number. Now let us start with the problem we have. So evaluate limit x approaches to plus infinity 3x minus 1 over x plus 2. Now, so how will you solve this type of problem? So there are two methods to solve this problem. Now we will solve here as limit x approaches to plus infinity. I'm taking the x in the numerator common factor. So you will get 3 minus 1 over x. If you multiply, you will get this term. So if you multiply 3x minus x cancel, you will get 1 over. So I'm taking the same thing, x common in the denominator, highest power of x in the denominator. So you will have 1 plus 2 over x. So it get cancelled. This and this get cancelled. As limit x approaches to plus infinity, 1 over infinity as per this rule. If you apply in the limit x approaches to 1 over x, it becomes to 0. Therefore, this part equals 0 and this part is equal 0. So you will get the value is equal. So 3. So answer is 3. Now there is a one shortcut method thereafter we can apply here. So thereafter we will have only I take the common factor, that is the highest. There is at another methods you have, that is take the highest power of x in numerator divided by the highest power in the denominator. Highest power in denominator. So what is the value here? So suppose if you have this function limit x approaches to plus infinity, I am taking the highest power of x. What is the highest power of x here? Along with the coefficients, along with the sign, 3x over. Here the coefficient highest power is x. So x will cancel. If you apply the limit for a constant, the answer will be x. So thereafter, we use this shortcut method to solve the problem. We use this method, which is the best method. We will take the highest power of the numerator and denominator of x. Highest power of x in the denominator, highest power of x in the numerator. So this is just you have to divide. Now let us go with the next one. So limit x approaches plus infinity, and here x square plus 5x minus 6 over this 2x square minus 1. So I will solve this method by using the same technique. So take the highest power of x in the numerator and take the highest power in the denominator. You will get a limit x approaches to plus infinity. So the highest power of x in the numerator is x square over. What about the denominator? It is minus 2x square. X square cancel. So this is 1 over 2. When you apply the limit for the 1 over 2, you will get a constant, same value. Now we will solve one more. Suppose if you have limit x approaches to plus infinity is x square minus 5, and here it is 2x square 2x cube plus 5 whole square over x power 4 plus 1, 3x square plus 1. Now we will have here, take the highest power in the numerator and denominator, what will happen? So this is x approaches to plus infinity. The highest power for the first term is x square. This term is over. Now what about this term part? 2x power 3 whole square. This is also over. What about the denominator? X power 4. And here, so this part is 3x square. 3x square. Now you have to simplify. So what is the simplify here? Limit x approaches to plus infinity. This is x power 2. When you apply the power, you will get 8x power 6 over 8x power 6 over, this is x power 4 and 3x square. So what are the cancel term here? So this is x square with the x square cancel. Now here it get cancelled, you have a remaining 2. So when you apply the limit x approaches to plus infinity, what are the terms you have? 8 over 3 x to the power 2. So when you apply the limit for the x, it becomes the whole thing will be infinity. So this is the value you have. Now let us go with the next problem. Limit x approaches to plus infinity and square root of 1 plus 4x power 6 over 2 minus x power 3. Now what is the rule? Take the highest power in the numerator and denominator. So if you take the numerator, what happened is square root of 4x power 6 is the highest power of x in the numerator. Along with the power, along with the root you have to take. And then we will have a denominator minus x power 3. Now apply the root for both the terms you have, 2x power 3 over minus x power 3. So therefore it get cancelled. So the value will be minus 2. When you apply the limit for the minus 2 is a constant, there is no x, you will get a constant as it is as per the property. So we will solve two more problems here. Yeah. Number 4. Limit x approaches to plus infinity, and here x over square root of x square minus 1 plus x. So this is a somewhat special problem here. So why it is special? Because if you take this part, the highest power in the numerator, what happened? This is the x. But what about the denominator? In the denominator, you have a two terms. What are they? So this is the one, this is one. So what is the highest power here? This is root x square. This term is over. Plus, because of the plus, this is, we have to take it two times. Now limit x approaches to plus infinity, and then x over, it is x plus x. So which in turn implies x approaches to plus infinity, x over 2x. So x with the x cancel. So the answer will be 1 over 2. So this is 1 over 2. This is a constant. When you apply the limit, it becomes a same thing. Now the last problem of this here, limit x approaches to plus infinity, or root 4x square plus 3x plus 2x. So what happened? So how will you do this one? So because here, since we don't have a denominator and it is a given function is a rational function, so root function, radical function. So now I have to multiply the conjugate of this term. What is the conjugate for this one? It is square root of 4x square plus 3x minus 2x over square root of 4x square plus 3x minus 2x. Now here we will have limit x approaches to plus infinity. So in the denominator it is no change here. So it is square root of 4x square plus 3x minus 2x. And in the numerator you will have this part is a. This part is a, b. This is a and this is b and this is a minus b. So the rule is a square. The root will be cancelled. 4x square plus 3x minus 4x square, which is also 4x square. Now then it get cancelled. Now this is a simplified answer you have. Limit x approaches to plus infinity, 3x over square root of 4x square plus 3x minus 2x. So what happened here? Now I will take the highest power in the numerator. Limit x approaches to plus infinity, 3x over, what is the first part? Because of the minus, I have to take the common factor of this one and this one. So here it is root 4x square for the first term. For the second term, it is minus 2x. Now this implies limit x approaches to plus infinity, 3x over 2x minus 2x. So it becomes a 0. It becomes undetermined. So it cannot be 0. It should be positive. So therefore it is the infinite. Limit doesn't exist. Suppose we will change the question here. Suppose if you have here minus, then it should be a plus here. It should be minus. Then I multiply with the plus. So it get cancelled. Here it is plus and here it will be plus and then it will be plus again plus. Now the rule is limit x approaches to plus infinity. It is 3x over 4x. X with the x cancel. So answer will be 3 over 4. 3 over 4 is the answer. Now similarly, if you want to calculate the minus infinity, I will solve one problem in the minus infinity. So limit x approaches to minus infinity and then it is 3x minus 1 over x plus 2. So here there is a minus. So how will you solve this type of problem? Now whenever you will have a minus, just convert the variable in terms of t. So convert the variable in terms of t. Suppose if you have, I will change this one as t. Let us substitute x equals t minus t. Then t approaches to plus infinity. So I just convert the x in terms of t. So you will get here 3 times of minus t minus 1 over minus t plus 2. So as usual, thereafter it is the same story you have to write. So therefore you will have what? Limit x approaches t approaches to plus infinity minus 3t over minus t. So minus t cancel. So answer will be 3. So this is what we will have. Now let us solve the same problem here. We will have plus infinity and minus infinity. So we will solve, this is minus 2. I will solve the same problem with the plus infinity, minus infinity. What happened? Let us check. So this one, we have limit x approaches to minus infinity and square root of 1 minus 4, 1 plus 4x power 6 over 2 minus x. So since it is given as a minus infinity, I have to convert in t. So x equal minus t and t approaches to plus infinity. So what happened? This given function, it become t approaches to plus infinity square root of 1 plus. So if I substitute t power 3, so you will become what? So t power 6 as it is. Why? Because the t power minus 6, which is equal t power 6. Now in the denominator minus, it becomes minus, that is t whole power 3. So minus t power whole power 3 is nothing but minus t power 3 cube. Now therefore the equation implies limit root 1 plus 4t power 6 over 2. This become minus of minus, it become plus t power 3. Now it is as usual the same thing. We will do it for the plus infinity. Take the highest power in the numerator. The highest power in the numerator is square root of 4t power 6 over t power 3. Now when you apply the limits separately, what happened? It becomes 2 t power 3 over t power 3. So t power 3 cancel. So answer will be 2. So if you apply the limit as x approaches to minus infinity, answer is 2. When you approaches to plus infinity, the answer is minus 2. So be careful while doing this one. So whenever you will have a minus infinity, convert the whole problem in terms of t by substituting the x equal minus t. Then the limit, it becomes t approaches to plus infinity. Once it is done plus infinity, it is a regular case. You can do it, solve the problem. Thank you.